Tucked away in an isolated mountain village in the Turkish Black Sea region lies a peculiar commodity. Every spring, villagers climb out the mountainside and scour the rocky edges for one thing: beehives. What makes these Turkish beehives so special is their honey, produced from the nectar of the rhododendron flower. This is no ordinary honey, however. Mixed with the naturally occurring hallucinogenic compounds, this new breed of honey is called mad honey. Hello, my name is Vince Wong, and today I'm going to be talking about the biopsychological effects of psychedelic honey, aka mad honey. The origin of mad honey can be traced back to the Turkish Black Sea region, where the area is abundant in a certain type of rhododendron. Early accounts of this honey can be traced as far back as the Greeks, and for centuries the local Turkish population considered the honey a delicacy. Some villages even went as far as to hold the honey in religious significance. However, mad honey is not just exclusive to Turkey. This honey can be found all over the temperate climate zone, from Nepal to even the Appalachians. Obtaining mad honey can be particularly dangerous, as bees tend to make their hives high up in the cracks and crevices of mountainsides. But why go through all the trouble just to grab some honey? One of the main reasons why the Turkish peoples go to such great lengths to harvest the honey is because of its supposed medicinal properties. Local village doctors have claimed that the honey is a potent aphrodisiac, can cure minor illnesses such as the common cold or fever, and can even be used in place of local anesthesia. Within the nectar of certain rhododendrons and azaleas are neurotoxic compounds known collectively as granotoxins. These compounds are then mixed into the honey that the bee produces. Another compound that can be found in mad honey is a psychoactive agent known as psilocybin. This is what causes hallucinations, and is the same compound found in psychedelic mushrooms. Both of these compounds affect two parts of the brain. Granotoxins affect a portion of the brainstem called the medulla oblongata. This crucial region of the brainstem controls all of the involuntary life-sustaining functions, such as breathing, swallowing, and most importantly, heartbeat. Damage to the medulla could result in the inability to perform these processes. Most of the concern surrounding mad honey is how much it negatively affects this part of the brainstem when consumed in large quantities. Psilocybin, on the other hand, affects the prefrontal cortex. This region of the brain regulates critical thinking, perception, and emotions. Damage to this critical structure can result in the alteration of personality and behavior, negatively affect critical thinking, and make it difficult to control one's emotions. Some of the short-term side effects include dizziness, blurred vision, diplopia or double vision, nausea, impaired consciousness, extreme perspiration, and vivid hallucinations. Most of the long-term effects are centered around the cardiovascular system. Granotoxins and psilocybin are neurotoxins. Over time, these will negatively impact the brain and lead to an increase in the degeneration of the white matter in our brains. Also, the constant exposure of granotoxins to our medulla oblongata can lead to the inability to regulate the basic life-sustaining functions, such as breathing, swallowing, and heartbeat. These compounds made researchers curious about the possible implementation of mad honey as a medicine. A study was conducted by a research team at the Karadeniz Technical University in Turkey, where mice with painful diabetic nerve pain were fed honey mixed with granotoxins. At the end of the experiment, the researchers concluded that the results from this experimental study indicate that GTX, or granotoxins, exhibits analgesic activity and has potential benefits against painful diabetic neuropathy. This is compatible with the widespread use of GTX containing mad honey for alleviating pain. Also, researchers at Johns Hopkins University have found that psilocybins can reorganize the networking of neural pathways. This has led to the possible implementation of psilocybins as an antidepressant. In summation, mad honey has its roots steeped in antiquity, and just recently some of the mystery surrounding this honey has been lifted due to scientific research and analysis. The biopsychological effects are numerous, but maybe one day researchers will find a way to isolate the positives so that we can all get a taste of this psychedelic treat.